In the first semester, we made object detection experiments with YOLO V7 to test that a higher rate of object detection can be made on thermal image than RGB image and to see statistics. Here's the official YOLO V7 repository. We can see that they improved the YOLO rather than more than YOLO V5 and YOLO V3, and we trained LLVIP visible infrared paired dataset. It consisting of 12,025 RGB thermal image pairs with YOLO 7 as RGB and thermal separately. We trained them. Then we made object detection in RGB and thermal images. Here we can that in the LLVIP dataset repository, they also mentioned that how to train and test with YOLO V5, but we improved it and we made our experiments with YOLO V7. With the results we have obtained, that we have seen that we can detect objects with higher success in thermal image, as we can see in here. This is the object detection results of visible images, and this is the object detection results of thermal image. And in thermal image, we can have much more success. After YOLO V7 experiments in the first semester, we examined various GAN algorithms for the second semester with our supervisor. Our aim was to convert RGB image into thermal images with the image-to-image translation logic, and we thought that pix-to-pix and cycle GAN would be suitable for this job. I worked on pix-to-pix, and my project partner Yuşa worked on cycle GAN. Pix-to-pix is a traditional generative adversarial network designed for image-to-image translation tasks. It learns a mapping from input image to output images, such as converting black and white photos to color or transforming sketches to photorealistic images. And we tried to use it for translating RGB image to thermal image. Its effectiveness has been demonstrated in various applications. Pix-to-pix requires paired images for training, which means it needs corresponding images in two different styles or modalities. And here's our pix-to-pix code in my repository. Since we did not have enough equipment, I made the pix-to-pix train and test bases using Google Colab Pro. We trained with 32 sizes and 40 epochs. Pix-to-pix uses, as we can see in here, L1 and L1 and GAN loss as loss functions. But afterwards, I implemented the perceptual loss function using VGG16 myself to get better results. But there was no significant change in the results. And as we can see in the results we have obtained, we think that if we have a better equipment and can develop an algorithm focused on thermal image conversion by focusing more on the algorithm, we can successfully convert our RGB image into thermal image. And in our website, we mentioned that our paper YOLO V7 code, pix-to-pix code, cycle GAN code, and results.
Implementation of our project. About code, model pi has generator and discriminator structure. Train pi has configurations for training which can be changed, and also implementation of model pi classes. I can show model pi classes here. We use PyTorch to create our structure. It has few classes, which main classes are discriminator and generator classes. For training, we use data loader from PyTorch, some torch vision tools, some OS, and matplotlib for plotting our losses. Hyperparameters are changeable, except the input image is always resized to a square 256 by 256, or it can be changed to something like 512. Pre-processing has also random flip for training, which is good for training. Initialization of generators and discriminators, which we use from model py file. Optimizers here for generator and discriminator. For adversarial and cycle constancy loss, for adversarial loss we use mean square error loss from torch, PyTorch. For cycle constancy loss we use L1 loss. These are for plotting, which I said before. We print at start of each epoch. We save the models at each second epoch, and we save some fake images to see how it's going the training. It says plot show, but it doesn't work on very well, so we also save it, which can be used at the Jupyter notebook, which you can see the training is done. For test configurations and testing models, by default 10th batch, which I will show here very fast. By default it takes 10th, but you can change it if you trained more or trained less or uploaded another model. For class and image structure, A is the thermal image, B is the RGB image, and structure is like this because data loader from PyTorch you wants this.